Welcome, everyone, to the AI Feature Specification Workshop part of our AI for Product Development series. Today, we're diving into one of the most critical yet often overlooked aspects of building successful AI-powered products, crafting clear, comprehensive feature specifications. This workshop is designed to be hands-on and highly practical. Whether you're a product manager, designer, engineer, or data scientist, you'll walk away with tools and techniques to define AI features that not only meet technical requirements, but also deliver real value to users. Why does this matter? Because AI features are fundamentally different from traditional software components. They're probabilistic, data-driven, and often unpredictable. That means our specs need to go beyond the usual functional requirements. We need to think about user outcomes, data dependencies, confidence thresholds, and how the system behaves when things go wrong. Over the next hour or so, we'll explore the core components of a robust AI feature specification, look at common pitfalls, and work through a real-world example. By the end, you'll have a working template and the confidence to apply it to your own product development efforts. Let's get started. Let's take a quick look at what we'll be covering in this lesson. We're going to walk through the full life cycle of creating a high-quality AI feature specification, starting with the fundamentals and ending with a hands-on exercise that puts everything into practice. We'll begin with an introduction to AI feature specs, where we'll explore what makes AI specifications unique compared to traditional software specs and why that distinction is so important. Then we'll move into the core specification components. These are the 5 essential building blocks that every AI feature spec should include. Think of them as your blueprint for success. Next, we'll dive into defining acceptance criteria. This is where we shift from vague goals to measurable standards. You'll learn how to set clear thresholds for quality, performance, and reliability, especially important when dealing with probabilistic AI outputs. We'll also cover edge case handling, which is often the most overlooked part of AI development. You'll learn how to anticipate failure modes and design for resilience, ensuring your feature behaves predictably even when things go wrong. Finally, we'll wrap up with a hands-on exercise. You'll choose a real or hypothetical AI feature and build out a complete specification using the framework we've discussed. By the end of this session, you'll have a working template and practical experience that you can take back to your team and apply immediately. Let's dive in and start building smarter, more reliable AI features together. Now let's talk about why AI features require a fundamentally different approach to specification than traditional software features. In conventional software development, we're dealing with deterministic logic, meaning that given the same input, the system will always produce the same output. This predictability makes it relatively straightforward to define requirements and test outcomes. But AI doesn't work that way. AI features are probabilistic by nature. They operate in a space of uncertainty, learning from data and adapting over time. That means the same input might produce different outputs depending on the model's training, the context, or even the randomness inherent in the system. This shift from deterministic to probabilistic behavior changes everything about how we write specifications. Instead of defining exact outputs, we need to specify acceptable ranges of results. We must account for data dependencies, what data the model needs, how clean or biased it is, and how it affects performance. We also need to consider ethical implications such as fairness, transparency, and bias mitigation. In short, AI specifications must be more flexible, more thoughtful, and more user-centered. They need to anticipate variability and guide the system toward consistent, trustworthy behavior. This is why a well-crafted AI feature spec is not just a technical document, it's a strategic tool for building better products. Let's talk about what happens when AI feature specifications are incomplete, vague, or missing altogether. The consequences aren't just technical, they ripple across development timelines, user experience, and even the business itself. From a development perspective, poor specs lead to extended iteration cycles. Teams spend weeks or months building features that don't align with stakeholder expectations. Misalignment causes rework, delays, and frustration. Without a clear spec, scope tends to drift, features balloon in complexity, and the original intent gets lost. On the user experience side, the impact is just as severe. Inconsistent AI behavior can confuse or frustrate users. Outputs that seem random or unexplainable erode trust. And when users can't understand or predict how the AI will behave, they're less likely to adopt it no matter how powerful it is. Then there are the business risks. Ethical and compliance violations can arise if the AI behaves in biased or opaque ways. Brand reputation can suffer if users feel misled or harmed. And perhaps most painfully, companies can waste significant investment on AI initiatives that ultimately fail not because the technology didn't work, but because the team never clearly defined what success looked like. One senior product manager at a Fortune 500 company summed it up perfectly. We spent 6 months building an AI feature that didn't match what users actually needed because we never clearly specified how it should behave in edge cases. That's the cost of inadequate specs. and it's exactly what we're here to prevent. Now that we understand why AI features require a different kind of specification, let's introduce the 5 core components that form the foundation of a strong AI feature spec. These components are designed to help cross-functional teams align on what the AI feature should do, how it should behave, and how success will be measured. First, we have feature definition, user outcomes. This is where we clearly articulate the user problem the AI is solving and define what success looks like from the user's perspective in it, just from a technical standpoint. Second, we specify the input data requirements. AI features are only as good as the data they consume. This section outlines what data is needed, where it comes from, and what quality standards must be met. Third, we define the output specifications. Unlike traditional features, AI outputs are variable. Here, we describe acceptable output formats, quality thresholds, and stylistic guidelines to ensure consistency and brand alignment. Fourth, we address interaction design. This includes how users interact with the AI, how feedback is collected, and how the system communicates its confidence and reasoning. It's about making the AI feel intuitive and trustworthy. And finally, we cover edge cases, error handling. This is where we anticipate failure modes and define how the system should respond when things don't go as planned. It's critical for building resilient, user-friendly AI experiences. Together, these 5 components form a comprehensive framework that ensures your AI features are well-defined, testable, and aligned with real user needs. In the next few slides, we'll break down each component in detail.
Let's begin with the first and arguably most important component of an AI feature specification: feature definition and user outcomes. This is where we shift the focus from what the AI can do to what the user actually needs. It's easy to get caught up in the technical capabilities of AI, but if we don't anchor our specs in real user problems and outcomes, we risk building features that are impressive, but irrelevant. Start by asking, what specific user problem does this AI feature solve? Be precise. Then, define success from the user's perspective. What does a good experience look like? What's the primary job to be done? And how will we measure whether the feature is delivering value? The goal here is to define concrete user outcomes, not just technical goals. For example, let's say we're building a smart email composer. The problem we're solving is that users spend too much time writing routine emails. The desired outcome? Reduce email composition time by 50% while maintaining the user's authentic voice and message intent. That's a clear, user-centered goal. And how do we measure success? One possible metric is the percentage of suggested drafts that users accept with minimal edits. That gives us a tangible way to evaluate whether the feature is working as intended. By grounding your specification in user outcomes, you ensure that the AI feature is not just functional, but meaningful. This sets the tone for every other component of the spec. The second core component of a strong AI feature specification is input and data requirements. This is where we define what the AI needs in order to function effectively, and it's absolutely critical. AI systems are only as good as the data they're built on and the inputs they receive. If we don't get this part right, everything downstream suffers. Start by identifying the data sources. What existing user data, content, or real-time inputs does the feature need access to? This could include behavioral data, historical interactions, sensor inputs, or external APIs. Be specific. Vague references to user data won't cut it. Next, define data quality thresholds. What's the minimum level of completeness, accuracy, or freshness required for the feature to perform reliably? Poor data quality leads to poor AI performance, so this needs to be clearly documented. Then, outline the user inputs. What will users explicitly provide to guide the AI's behavior? This could be preferences, prompts, selections, or corrections. Understanding how users interact with the system helps shape the AI's responsiveness and personalization. Finally, don't forget about constraints. What limitations apply to data usage? Are there privacy considerations, regulatory requirements, or ethical boundaries that must be respected? These constraints are not just legal, they're foundational to building trust with users. By clearly specifying input and data requirements, you ensure that your AI feature is grounded in reality. You give your team a roadmap for what data needs to be collected, validated, and protected. and you set the stage for reliable, responsible AI behavior. Now let's explore the third core component of an AI feature specification: output specifications. This is where things really start to diverge from traditional software specs. In conventional systems, we define exact outputs. But with AI, we need to think in terms of acceptable ranges, quality characteristics, and user experience alignment. Start with format specifications. What should the output look like? Define its structure, length, and composition. Is it a block of text, a ranked list, an image, or audio? What formats are supported, and how will the output integrate with existing UI components? These details help ensure consistency and usability. Next, define quality thresholds. This includes accuracy requirements, how close the output needs to be to a correct or useful result, and how that accuracy is measured. Also consider performance expectations like speed and resource usage. And don't forget confidence scores. What's the minimum confidence level required for the AI to take action or present a result? Then, layer in style and tone guidelines. AI outputs should reflect your brand's voice and values. Should the tone be formal, friendly, technical, or empathetic? Are there personas the AI should emulate? What guardrails are in place to ensure content appropriateness and avoid offensive or misleading outputs? For each of these characteristics, specify both acceptable ranges and ideal targets. This gives your team flexibility while maintaining quality and consistency. It also helps QA teams know what to test for and gives stakeholders a clear understanding of what good looks like. By defining output specifications thoroughly, you ensure that your AI feature delivers results that are not only technically sound, but also aligned with user expectations and brand standards.
The fourth core component of an AI feature specification is interaction designate. This is where we define how users engage with the AI, how the system responds, and how trust is built through transparency and control. A well-designed interaction model can make the difference between a feature that feels intuitive and empowering and one that feels confusing or even intrusive. Start by specifying user controls. How can users guide, correct, or override the AI's decisions? This might include editable suggestions, sliders for personalization, or options to reject and regenerate outputs. Giving users agency helps them feel in control and builds confidence in the system. Next, define feedback loops. How does the system learn from user interactions? Are there thumbs up, down buttons, correction prompts, or implicit signals like edits and deletions? Capturing this feedback is essential for continuous improvement and personalization. Then, consider confidence communication. AI systems often operate with varying levels of certainty. How do we convey that to users? Should we show confidence scores, use visual indicators, or provide explanations? Communicating uncertainty helps users make informed decisions and prevents over-reliance on the AI. Transparency is also key. Include transparency mechanisms that help users understand why the AI produced a specific output. This could be through tooltips, traceable logic, or links to source data. When users understand the why, they're more likely to trust the what. Finally, think about progressive disclosure. How do we provide context without overwhelming the user? This might involve layering information, offering optional details, or simplifying the interface for novice users while allowing deeper exploration for experts. The fifth and final core component of a robust AI feature specification is edge cases and error handling. This is where we prepare for the unexpected, and it's one of the most valuable parts of the entire spec. While many teams focus on the happy path, where everything works perfectly, real-world usage is messy. Users behave unpredictably, data can be incomplete, and systems can fail. Your spec needs to account for all of it. Start by identifying potential edge cases. These are scenarios where the AI might struggle, unusual inputs, resource constraints, or atypical user behaviors. Be specific. Don't just say low data quality, describe what that looks like and how it affects the feature. Next, define graceful degradation. What should the system do when ideal performance isn't possible? Should it fall back to a simpler rule-based system? Should it notify the user and offer alternatives? The goal is to maintain usability and trust, even when the AI can't deliver its best. Then document recovery paths. If the AI makes a mistake, how can users and the system recover? Can users correct the output? Is there a feedback loop to learn from errors? Can the system retry or escalate to human support? These mechanisms are essential for resilience and user satisfaction. A common mistake is to only specify the ideal behavior. But in practice, the most valuable part of your spec may be how the feature behaves when things go wrong. Anticipating failure modes and designing for recovery isn't just good engineering, it's good product thinking. By thoroughly addressing edge cases and error handling, you build AI features that are not only smart, but also trustworthy, resilient, and ready for the real world.
Now that we've covered the core components of an AI feature specification, let's talk about how to define effective acceptance criteria. This is where we move from concept to validation, ensuring that the feature performs as intended and meets quality standards in a measurable way. Traditional software often relies on binary pass-fail criteria. Either the feature works or it doesn't. But AI doesn't operate in absolutes. It's probabilistic, and its performance varies depending on context, data, and user behavior. That means our acceptance criteria need to be more nuanced and statistically grounded. Start with statistical thresholds. For example, you might require that the feature achieves greater than 92% accuracy on a benchmark test set. This sets a clear performance bar while acknowledging variability. Next, consider distribution requirements. It's not enough for the AI to perform well overall. It must perform consistently across different user groups. For instance, error rates should be balanced across demographics to avoid bias and ensure fairness. Then, define performance boundaries. These might include response time limits, such as the system must respond in under 1.2 seconds for 99% of requests. This ensures the feature is not only accurate, but also fast and scalable. Finally, use quality bands to capture a range of acceptable outcomes. For example, you might specify that outputs must meet acceptable quality for 99% of inputs and excellent quality for at least 80%. This gives you a way to evaluate performance across different tiers and use cases. The key is to make your criteria measurable and testable. They should be grounded in real-world usage and aligned with user expectations. When done right, acceptance criteria become a powerful tool for guiding development, validating performance, and ensuring your AI feature delivers consistent value. Now it's time to put everything we've learned into practice. In this hands-on exercise, you'll build a complete AI feature specification using the framework we've just covered. This is your opportunity to apply the 5 core components: feature definition, input requirements, output specifications, interaction design, and edge case handling to a real-world scenario. You can choose one of the provided examples or use a feature from your own product. The options include a content recommendation engine that suggests relevant content based on user behavior and preferences, a customer support assistant that handles Tier 1 inquiries by identifying intent and delivering helpful responses, a data anomaly detection system that flags unusual patterns in business metrics for further investigation. Here's how the exercise will work. First, complete the specification template for your chosen feature. You'll have 15 minutes to define each of the 5 core components. Then, identify at least 3 critical edge cases, scenarios where the AI might fail or behave unpredictably. You'll have 5 minutes for this step. Next, define measurable acceptance criteria. Think about statistical thresholds, performance boundaries, and quality bands. You'll have 5 minutes to outline these. If you're working in a group, take an additional 5 minutes to review another person's specification. Offer feedback, ask questions, and look for gaps or assumptions. This exercise is designed to be practical and collaborative. By the end, you'll have a working draft of an AI feature spec that you can refine and use in your own product development process. Let's get started.
Now it's time to put everything we've learned into practice. In this hands-on exercise, you'll build a complete AI feature specification using the framework we've just covered. This is your opportunity to apply the 5 core components: feature definition, input requirements, output specifications, interaction design, and edge case handling to a real-world scenario. You can choose one of the provided examples or use a feature from your own product. The options include a content recommendation engine that suggests relevant content based on user behavior and preferences, a customer support assistant that handles Tier 1 inquiries by identifying intent and delivering helpful responses, a data anomaly detection system that flags unusual patterns in business metrics for further investigation. Here's how the exercise will work. First, complete the specification template for your chosen feature. You will have 15 minutes to define each of the 5 core components. Then, identify at least 3 critical edge case scenarios where the AI might fail or behave unpredictably. You'll have 5 minutes for this step. Next, define measurable acceptance criteria. Think about statistical thresholds, performance boundaries, and quality bands. You'll have 5 minutes to outline these. If you're working in a group, take an additional 5 minutes to review another person's specification. Offer feedback, ask questions, and look for gaps or assumptions. This exercise is designed to be practical and collaborative. By the end, you'll have a working draft of an AI feature spec that you can refine and use in your own product development process. Let's get started. Let's walk through a complete AI feature specification for a customer support as a standard feature designed to handle Tier 1 customer inquiries by identifying intent and delivering relevant, helpful responses. This example will demonstrate how to apply all 5 core components of a robust AI spec. We begin with the feature definition. The problem we're solving is that customer support teams are overwhelmed with repetitive, low-complexity inquiries that slow down response times and reduce overall efficiency. The desired outcome? Automate Tier 1 support interactions to reduce average resolution time by 40%, while maintaining high customer satisfaction. That's a clear, measurable goal that aligns with both user needs and business priorities. Next, we define the input requirements. The assistant needs access to historical support tickets, product documentation, FAQs, and user account data. It also relies on real-time inputs like the customer's query, sentiment indicators, and interaction history. Data quality is critical here, especially for intent detection and context relevance. We also need to respect privacy constraints, ensuring sensitive data is handled securely and in compliance with regulations. Then we move to the output specifications. The assistant should generate concise, accurate responses in natural language, tailored to the customer's query. Outputs must include suggested actions, links to relevant resources, and escalation options when needed. Quality thresholds include a minimum 90% intent classification accuracy and a response latency under 1 second for 95% of queries. The tone should be empathetic, professional, and aligned with the brand's voice. Now let's look at interaction design. Customers should be able to clarify or rephrase their questions, escalate to a human agent, or provide feedback on the assistant's response. Confidence scores should be communicated subtly, perhaps, through phrasing like, "It looks like you're asking about," and transparency mechanisms should explain how the assistant arrived at its answer. Progressive disclosure helps avoid overwhelming users while still offering depth when needed. Finally, we address edge cases and error handling. Potential failure modes include ambiguous queries, unsupported languages, or missing account data. Let's walk through a complete AI feature specification for a data anomaly detection systema feature designed to identify unusual patterns in business metrics that may indicate issues, risks, or opportunities. This example will show how to apply all 5 core components to a feature that's critical for operational awareness and decision-making. We begin with the feature definition. The problem we're solving is that teams often miss early warning signs in complex datasets, leading to delayed responses to performance issues, fraud, or system failures. The desired outcome? Automatically detect anomalies in real time across key business metrics, reducing time to awareness by 60% and enabling faster, data-driven interventions. Next, we define the input requirements. The system needs access to time series data from business dashboards, transactional logs, user activity streams, and operational KPIs. It must ingest both historical and real-time data with minimum requirements for completeness, granularity, and freshness. Data constraints include handling missing values, ensuring secure access, and complying with internal data governance policies. Then we move to the output specifications. The output should be a ranked list of flagged anomalies, each with a confidence score, timestamp, affected metric, and a brief explanation of the deviation. Quality thresholds include a minimum precision of 85% and recall of 90% on benchmark datasets. Latency must remain under 500 milliseconds for real-time alerts. Now let's look at interaction design. Users should be able to drill down into anomaly details, dismiss false positives, and provide feedback on alert accuracy. The system should visualize trends and deviations, offer contextual explanations, and allow users to adjust sensitivity thresholds. Confidence levels should be clearly communicated, and transparency mechanisms should explain the basis for each detection, whether statistical, behavioral, or rule-based. Finally, we address edge cases and error handling. Potential failure modes include data outages, sudden metric shifts due to external events, and anomalies caused by system updates. In these cases, the system should degrade graceful flagging uncertainty, pausing alerts, or switching to fallback detection models. Recovery paths include reprocessing data, user overrides, and feedback loops to retrain detection algorithms.
To bring everything we've discussed to life, let's walk through a complete example of an AI feature specification. This one focuses on a content recommendation engine, a common AI feature used to personalize user experiences by suggesting relevant content. We start with the feature definition. The problem we're solving is that users struggle to discover relevant content in a large, diverse library. The desired outcome? Increase content engagement by 30% through personalized recommendations. That's a clear, measurable goal tied directly to user value. Next, we define the input requirements. The system needs access to user data like view history, explicit ratings, topic preferences, and demographic information. On the content side, it requires metadata, popularity metrics, freshness indicators, and topic classifications. These inputs help the AI understand both the user and the content it's recommending. Then we move to the output specifications. The output is a ranked list of 5 to 7 content items, each with a confidence score. To ensure diversity, the list must include at least 2 different content categories. This prevents the system from becoming too narrow or repetitive. Now, let's look at the acceptance criteria. We might require that the click-through rate on recommended content is at least 25% higher than non-personalized content. Latency must stay under 250 milliseconds for 95% of requests. And for new users, those with fewer than 5 interactions, the drop-off in engagement should be less than 15% compared to established users. Finally, no single content category should dominate more than 60% of recommendations for any user, ensuring variety and fairness. This example brings together all 5 core components in a way that's clear, actionable, and aligned with both user needs and business goals. It's a great model for your own specifications. As we wrap up today's workshop, let's revisit the key takeaways and outline your next steps for putting these concepts into action. First, remember the 5 core components of an AI feature specification: feature definition and user outcomes, input and data requirements, output specifications, interaction design, and edge case and error handling. These aren't just theoretical, they're practical tools for building AI features that are clear, testable, and aligned with user needs. Second, consider the impact of good specs on your development process. Teams that use well-defined AI specifications report up to 3x faster implementation. That's because clear specs reduce ambiguity, prevent rework, and foster better collaboration across disciplines. Third, recognize that 80% of AI feature issues, from poor performance to user mistrust, can be traced back to incomplete or vague specifications. By investing time upfront in writing strong specs, you dramatically reduce the risk of failure and increase the likelihood of delivering real value. So what's next? Start by downloading the AI feature specification template from our resource library. Apply it to your next AI feature, whether it's in discovery, design, or development. Schedule a spec review with your cross-functional team to ensure alignment. Then, iterate based on implementation feedback and share your learnings with the broader product organization. Above all, remember this: good AI specifications balance technical precision with user-focused outcomes. They acknowledge the probabilistic nature of AI while setting clear boundaries for acceptable performance. When done right, they become a strategic asset, driving better products, faster delivery, and stronger user trust. Thank you for participating in this workshop. Now go build something amazing.